Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 5.4 guided notes on converting rates. We also call this dimensional analysis. You can convert rates using a method called dimensional analysis. It is the process of including units of measurement as factors when you compute. For example, since you know that 1 hour equals 60 minutes, you can use the conversion factor 1 hour over 60 minutes or 60 minutes over 1 hour. We'll talk about how we know whether the hour goes on the top or the bottom or vice versa, how we know what order we need to put those values in. Your conversion rates are in your guided notes in several sets of guided notes, including this one, and you may use those conversions as we're working through these problems. And on a test or a quiz, should you need any of the conversion factors, I will make sure to provide you with them. So we're going to start with some examples of converting one unit of measure. Now, there are other ways to do this besides using dimensional analysis. However, I do show you dimensional analysis because it's something you'll see again in your high school science classes, actually. I believe in chemistry you use dimensional analysis and possibly also physics as well. So let's take a look at a couple of examples. So example one on the left is on converting one unit of measure. So it says to convert 45 miles per hour to miles per minute. So we are converting our hours into minutes. Go ahead and highlight that here. Converting our hours into minutes. So the first thing I do is I'm given 45 miles per hour and I write that as a fraction, 45 miles over 1 hour. And then I need to look for a conversion factor between hours and minutes. I know that 1 hour is 60 minutes. So that is going to be my second fraction, but I have to figure out what number goes where. Does the 1 hour go on the top or the bottom? So since hours was on the bottom here, I'm going to put hours on the top. What that allows us to do is cross off our units of measure in this case. Since they're diagonal from each other, we have one on the top, one on the bottom, kind of like when we cross-reduced when we multiplied fractions previously. So if hours has to go on the top, then I'm going to put 1 hour over 60 minutes. Again, I make sure to keep the same conversion factors. I don't flip-flop the 1 and the 60. 1 hour is equivalent to 60 minutes. Then I multiply straight across. So I have 45 miles left on the top, 60 minutes left on the bottom, and then I divide to find my solution. Notice how I get miles per minute, which is exactly what I want to get. We end up with a solution of 0.75 or 3/4 miles per minute. Let's take a look at example 2, where we convert one unit as well. The average teen spends $650 per year on cell phone apps. How much is this per week? So we start off by writing $650 in 1 year as a fraction. We are trying to convert our years into weeks. So the conversion factor here is that there are 52 weeks in 1 year. So years was on the bottom, so we want years to be on the top. So 1 year goes on the top, 52 weeks on the bottom. Notice how the second fraction is just a conversion factor for us. We can cross off our years, the label, not the numbers, although these are just ones anyway. Multiply straight across, we get $650 on the top, 52 weeks on the bottom. That's going to get us the amount of dollars per week when we divide. That's going to get us $12.50 per week. All right, let's take a look at problem number 1. A company can produce 1,250 gallons of ice cream per minute. How many gallons can they produce each hour? So here's the deal. I'm given 1,250 gallons per minute. That's the fraction I need to begin with. 1,250 gallons per minute. Then I know that I need to convert my minutes into hours. So I need a conversion between minutes and hours. Well, I know that there are 60 minutes in 1 hour. Minutes was on the bottom, so I put my 60 minutes on the top of this fraction, my 1 hour on the bottom. Again, this is just this conversion factor. I'm going to highlight this in green. So this conversion factor is my second fraction. Notice the multiplication between those two fractions since I'm multiplying this by this. So we take 1,250 times 60 on the top. That's going to get us the number of gallons. And then on the bottom, we're going to have our number of number of hours because hours is left here. So we get 75,000 gallons per hour. Now, might some of you realize, well, I know that there's 60 minutes in an hour, so if it's 1,250 gallons per minute, I just need to multiply by 60. Yeah, that's what we're doing here. But sometimes I have students who don't know whether they need to multiply or divide. So that's where dimensional analysis, setting up your conversion factors as fractions, can really come in handy. It doesn't mean you can't do it a different way, but you still are expected to show your work, meaning what did you do to get your solution? 1,250 times 60. I do like to show you dimensional analysis though, because again, I know you'll see it in one of your high school science classes. Number 2, the average teen spends 1,820 hours per year on their cell phone. How many hours per week is this? And I just randomly made this up, so don't go with this. We've got 1,820 hours per year that we're going to start with as our first fraction. And we know that we want to convert, go ahead and circle this, our years to weeks. So the conversion factor is the same as in example 2 up above. 1 year is 52 weeks. Years is on the bottom, so our 1 year is going to go on the top. Again, this conversion factor is one of our fractions, 52 weeks, 1 year. Just need to know what goes where. So 1 year is 52 weeks. The years cross off, so we have 1,820 hours on the top, 52 weeks on the bottom. We divide to get our solution, and we will get 35 hours per week. All right, I do have a couple of independent practice problems for you to try. Go ahead and pause the video and give these 2 questions a try. When you're ready, restart the video. All right, taking a look at number 1, it says to convert 20 gallons per minute to gallons per hour. So start with your 20 gallons per minute as your original fraction. We'll highlight that in yellow. There we go. It's going to be all of this information here. We want to convert our minutes to hours. So we know that there's 60 minutes in an hour, but I want my minutes to go on top. So 60 minutes on the top, 1 hour on the bottom. Notice how I can cross off my units of measure. Not the number itself, just the label. So we have 20 gallons times 60 on the top, which is going to get us 1,200 gallons, and then per hour on the bottom. So we have gallons per hour left. Take 20 times 60. We've got 1 in the denominator. It's just 1,200 gallons per hour. Let's take a look at number 2. We want to convert 4,420 hours per year to hours per week. So 4,420 hours per year is our first fraction. We want to convert our years to weeks. There's 52 weeks in a year. So the 1 year needs to go on the top, so it's diagonal from this guy, 52 weeks on the bottom. We have 4,420 hours on the top, 52 weeks on the bottom. This will get us the number of hours per week once we divide. That will get us 85 hours per week. All right, let's talk about how to convert 2 units of measure. So there are 3 examples typed in here for us. Just notice that on these examples, I'm not going to spend the time to go through them. You can certainly read through those. We will see some examples like example 5 where we're converting between customary and metric, or metric and customary. Metric is what most other countries use. Customary is what we use. There are 2 different conversions listed on your chart with all of the different conversions. There's, for example, liters to gallons, and then there's a gallons to liters. So if you use different ones, you might get slightly different answers just because those decimals themselves are slightly rounded. So just be aware of that you may get something that's a few tenths off. I calculated some of these using both conversion factors, and we were pretty close on most of them, but you may end up being like a tenth or a hundredth off sometimes. So just be aware of that when you convert between customary and metric. There aren't any of those on the unit test, but I still think they're beneficial to look at converting between customary and metric as well, since that is a really good real life concept or topic. So let's take a look at number 3. I just want to go right into our examples. You can always go back and read through some of these other ones as needed. It says to convert each rate using dimensional analysis, round to the nearest hundredth if needed. So number 30, I have 40 centimeters per second, and we're converting that to meters per minute. So the first fraction is really easy to come up with. It's what's given to us, 40 centimeters per second. So we'll start with that, 40 centimeters over 1 second. Now, we do want to convert our centimeters into meters. So we need a conversion between centimeters and meters. I know you work with this in science. There's 100 centimeters in 1 meter. So our next fraction, or our second fraction, is going to involve this conversion factor. Since centimeters is on the top, I'm going to put the 100 centimeters on the bottom. So 1 meter over 100 centimeters. We'll cross off our units of measure here in just a few moments. We also need to convert between seconds and minutes. Whoops, I don't want a line there. I do want an arrow. Let's get that. I want to convert between seconds and minutes. There are 60 seconds in a minute. You know this. You count them down every day at the end of the period. We've got seconds on the bottom of this first fraction, so 60 seconds is going to go on the top of our last fraction. And we'll highlight that in blue. Just keep everything nice and color-coded for us. Notice the multiplication signs between these, not equal signs, since we're going to be multiplying straight across. Now let's cross off. We've got centimeters here and here. We've got seconds here and here. And we're going to be left with meters per minute, which is exactly what we want in our solution. So let's take 40 times 1 times 60 on the top. That's 2,400 meters on the top. 1 times 100 times 1 is 100 minutes on the bottom. Now divide 2,400 by 100. That gets us 24 meters per minute. Oops, there is no number there. That's not helpful. We'll type it in. So we get 24 meters per minute. Let's take a look at number 4. This does take some practice to get a lot better at this. We've got 180 inches per minute, and we're converting to yards per hour. So first fraction, super easy. We've got 180 inches in 1 minute, which is what is given to us. We do want to convert between inches and yards. We don't have a direct conversion on our chart from inches to yards, but there are 3 feet in a yard, and every foot has 12 inches. So there are 36 inches in 1 yard. 3 feet in a yard, that's 36 inches. So inches was on the top. I want inches to go on the bottom. So 36 inches on the bottom, 1 yard on the top. This would be my second fraction. Now, because we have 2 conversions, we have a third fraction we need to have here. We're going to convert between minutes and hours. We definitely know that there are 60 minutes in 1 hour. So we had minutes on the bottom, so the 60 minutes will go on the top. So we have 60 minutes over 1 hour. Let's cross off our units of measure here. So we had inches and inches, again, not the number, just the label. We had minutes and minutes. We're going to be left with yards per hour, which is what I want in my solution. So we multiply straight across. 180 times 1 times 60 is 10,800 yards on the top. 1 times 36 times 1, which is 36 hours on the bottom. Take 10,800 yards divided by 36 hours, and we get 300 yards per hour. All right, let's take a look at a couple more of these, numbers 5 and 6. Number 6 will involve converting between metric and customary, so that's good practice for us to see. Number 5, we have 80 miles per hour. We're converting to feet per minute. So first fraction, super easy for us, is 80 miles in 1 hour. So there's our first fraction. We are trying to convert between miles and feet, so we might need to look up that conversion factor. But there are 5,280 feet in 1 mile. So since miles is on the top, I want the 1 mile to go on the bottom here. So I'll have 5,280 feet over 1 mile, which is our second conversion factor. And then we also want to convert between hours and minutes. We've seen this already. We know, of course, there are 60 minutes in 1 hour. So that will be, since I have hours on the bottom, I want the 1 hour to be on the top here. So I have 1 hour over 60 minutes. Now I often get asked by students, can we switch around the order of the fractions? You can. You will get the same solution. You'll have the same numbers on the top and the same numbers on the bottom, and you'll still get the same final answer. So here, let's cross off what we have. We have miles and miles. We have hours and hours. We're going to be left with feet per minute. That's what we want in our solution. So we take 80 times 5,280 on the top to get 422,400 feet on the top. 1 times 1 times 60, or 60 minutes on the bottom. Now we divide to get our solution. We will get 7,040 feet per minute. Let's talk a little bit about question number 6. So we've got 100 liters per day. We're converting that to quarts per hour. So for this, we want to start with 100 liters per day. It's our first fraction. Then we want to convert between liters and quarts. And there's a couple of different conversions on your guided notes, and you can use either of those. Let me see which one I chose. These are ones I don't have memorized. But there are 1.057 quarts in 1 liter. They also have 1 quart equals a certain number of liters. I don't remember what that value is, probably something pretty close to 1 as well. But that would mean you would flip-flop, like liters would still be on the bottom, but you would have a number down there. You'd have 1 quart on the top, but you still should get the same solution. I actually tried both ways, and they are very similar. But there's 1.057 quarts in 1 liter. Since liters was on the top here, I put the liters on the bottom. So either conversion factor works. This just happened to be the one that I chose to use here. And again, you can use your notes for that because even I don't have these conversions memorized. And then we're also converting between days and hours. So there are 24 hours in a day. Sometimes I have students who try to they try to put like, well, a half day is 12 hours or something. You don't need to go crazy, okay? Just have one of those numbers being a 1. 1 day is 24 hours. We have 1 day on the bottom here. We'll put 1 day on the top and 24 hours on the bottom. For example, sometimes students try to match these. They want this to be 100 liters down here, and they keep the 1.057 quarts up here, which is not correct. So be really careful with that. You don't need to go crazy and convert anything. Each of these fractions themselves will be a conversion factor, and then you just multiply straight across. So here we can get rid of our liters and liters. Let's try to get rid of that. It didn't work for me. There we go. Our days and days, and we're left with quarts per hour, which is exactly what we want. So we take 100 times 1.057, which is 105.7 quarts. On the bottom, we have 24 hours left. When we take 105.7 divided by 24, we get about 4.4 quarts per hour. If you want to round to the nearest hundredth, like it says, you can put 4.40 because there is like a 0 and then a 3 maybe after that. But it is about 4.4 or 4.40 quarts per hour. Again, if you use that other conversion between quarts and liters, which again is probably something like 0.9 liters in 1 quart, something like that. I don't know, might be, I'm trying to remember what it is. You'd have to look it up, but I don't have it in front of me right now. But whatever that conversion factor is, you should get something pretty similar. Now, are the numbers in this fraction going to look different? Yes. But again, you should get a pretty similar answer when we round it to the nearest tenth or hundredth. All right, I have a few independent practice problems for you to try. None of these involve converting between metric and customary, so that's kind of nice for us. Go ahead and give these a try. Pause the video. When you're ready, restart it, and we'll take a look at these solutions. All right, how'd you do with these? I hope pretty well. Dimensional analysis itself isn't that tricky, but it is something new and maybe a little different for you. So for number 1, you should get a solution of 5,280. Let's look at our work for this one. So we start with 60 miles per hour. What's given? We want to convert miles to feet. There's 5,280 feet in a mile, but since miles was on the top, the 1 mile goes on the bottom, 5,280 feet on the top. We also want to convert hours to minutes. There are 60 minutes in an hour. Since hours was on the bottom, we put hours on the top, so 1 hour, 60 minutes. And we're going to cross off these common units of measure here. We end up with feet per minute, which is exactly what we want. Take 60 times 5,280, which gets us 316,800 feet on the top, 60 minutes on the bottom. Divide to get our final solution of 5,280 feet per minute. Number 2, we've got 20 quarts per minute. We want to convert that to gallons per hour. So we should get a solution of 300 gallons per hour. Start with 20 quarts per 1 minute. There's 4 quarts in a gallon, so since quarts was on the top, 4 quarts goes on the bottom, 1 gallon on the top. Minutes to hours again, or vice versa in the last question. There's 60 minutes in an hour. Since minutes is on the bottom, we put 60 minutes on the top. And we'll just show you that we can cross these labels off here. And we end up with gallons per hour, which is exactly what we want. 20 times 60 on the top is 1,200 gallons. We've got a 4 left on the bottom. Take 1,200 divided by 4 gets us 300 gallons per hour. And number 3, you do have to convert between seconds and hours, so be careful there. You actually get a repeating decimal for this one. Let's talk about this. Start with 20 feet per second. We're converting to miles per hour. So in this case, we've got 5,280 feet in a mile. Since feet was on the top, I want feet on the bottom here. And then seconds to hours, you need to recognize that there's 3,600 seconds in an hour. How do I get that? Well, I take 60 times 60. There's 60 seconds in a minute, 60 minutes in an hour. So 3,600 seconds in 1 hour. Seconds goes on the top here. So again, when I cross off my units of measure, not the numbers, just the units, I end up being left with miles per hour, which is exactly what I want. 20 times 3,600 is 72,000 miles on the top, 5,280 hours on the bottom. Divide, you do get a repeating decimal, 13.63 repeating miles per hour. If your calculator gives you a 4 at the end, it's just rounding that last 3 up, but there's not truly a 4 there. All right, let's take a look at a couple of word problems related to conversions or dimensional analysis. Let's look at numbers 7 and 8. Number 7, a cheetah can run short distances at a speed of up to 75 miles per hour. How many feet per second is this? Let's take a look at this one. So first things first, this is really just a dimensional analysis question where we're converting 75 miles per hour into feet per second. So first fraction is 75 miles per hour. So we start there. We want to convert our miles into feet. Well, there are 5,280 feet in a mile. So 5,280 feet over 1 mile so that we can cross off our miles. And then we want to convert our hours into seconds. So if you remember from our last problem we just saw, there's 3,600 seconds in an hour. In this case, I want my hours to go on the top though, seconds on the bottom. So we're going to be left with feet per second. 75 excuse me, 75 times 5,280 is 396,000 feet on the top, 3,600 seconds on the bottom. We will divide to get a solution of 110 feet per second. All right, let's take a look at number 8. So this one does involve converting between metric and customary, so kilometers per hour to miles per minute. So start with what's given to us, which is 40 kilometers per hour. Excuse me. So you've got 40 kilometers in 1 hour. Let's convert our kilometers to miles. So the conversion factor I chose was at 0.621 miles is equal to 1 kilometer. That's going to allow us to cross off our kilometers here. Notice how kilometers on the top, kilometers on the bottom. There is another conversion rate for 1 mile equals a certain number of kilometers, a little bit over 1. So that would just kind of flip-flop what numbers are where, but you would get the same final solution. We want to convert hours to minutes. We know, of course, there's 60 minutes in an hour. 1 hour on the top, 60 minutes on the bottom. Cross off our hours. We're going to end up with miles per minute, which is exactly what we want here. So take 40 times 0.621. I did not round here. I got 24.84. On the bottom, we have 60 minutes. So take 24.84 divided by 60. I did not round it just because it's a short enough decimal. I got 0.414 miles per minute. So about a half mile per minute in this case. All right, so the last thing is easier, simple conversions where we're just converting a number to something else. So if I want to convert 38 feet to meters, I can start by writing 38 feet and look for a conversion factor between feet and meters. Again, there are 2 listed on your paper or your page, but 0.305 meters is equivalent to 1 foot. So I put 1 foot on the bottom, not foot on the bottom, I put 1 foot on the bottom and I've got meters on the top. So to find my solution, I can take 38 times 0.305, which is going to get me 11.59 meters. I did do it the opposite way using the other conversion between meters and feet. Again, I don't have it memorized, where I had to take 38 divided by a value, and I still got 11.59. Just ended up being a longer decimal that I would need to round. Number 10, we have 2 kilograms. We're converting that to ounces. So start with your 2 kilograms. Your conversion here is a little bit more complicated. So there is no conversion between kilograms and ounces. What I did was kilograms to pounds and then pounds to ounces. So a little more complicated here. So there's 2.203 pounds in a kilogram. And I put the 2.203 pounds on the top, 1 kilogram on the bottom. But since I want to convert to ounces, I also know that there's 16 ounces in a pound. So I do 16 ounces over 1 pound. And then I just have to multiply straight across. 2 times 2.203 times 16. I didn't round because, again, it was a short enough decimal. I got 70.496 ounces. Finally, number 11, our last example, 20 liters to gallons. Again, these are just really good examples if you're working with some science-related things. Start off with 20 liters. We're converting that to gallons, so the conversion factor I picked was 0.264 gallons to 1 liter. And again, we can cross off our liters here. And then just multiply straight across will get us the number of gallons. That will be 5.28 gallons. All right, I know I threw a lot of information at you here. The problems we want to pay most attention to are probably problems like number 7. The examples we saw here are really important to take a look at, as well as numbers, I would say 3, 4, and 5. Number 6 is converting between metric and customary. You're not going to have that on your test, but I still think it's beneficial for us to look at, especially as advanced students. But those are the questions I would say to pay particular attention to. Thanks for listening.